All right, we're live. Welcome to Insights by Design, the podcast where we remove the friction between information and insight. I'm Andrew Madsen. I'm joined by my brother, Michael Madsen.
Yes, I'm Michael Madsen. I'm an assistant professor at Arizona State University, and I specialize in user experience and technical communication. Who are you, Andrew?
I'm Andrew Madsen. I also work at Arizona State University. I'm the senior director of data analytics. And we jointly decided that this podcast would be a good way to find the intersection between user experience, analytics, and design to drive insights and business value. So, Michael, you brought up a good question. What is data? Do you want to jump into that?
No, I don't, because I'm not sure I have a good answer to it. But data is one of those new buzzwords that you hear in the media, in business reports, in education. Data is hot, but I'm not sure that we're always talking about the same thing when different people use the word data. It's almost like a Tower of Babel sort of situation. And I mean, correct me if I'm wrong, but I think data is usually just bits of stuff. It can be quantitative, it can be qualitative, but there tends to be a lot of it. How do you use it in the kind of work that you do up in the C-suite?
Well, you're right. I think often data is misunderstood because it's generally raw, it's unprocessed, and there has to be some kind of standard around how it was collected, and that standard can be misunderstood. So, from all kinds of data, there can be verbal data, video data, data in databases, but understanding where it came from, what the source was, how it was collected, all that's super important. And it's often not reviewed until there's a problem. So downstream from data, right, we're looking at the information, we're looking at charts and graphs, and if something doesn't look right, then we start investigating and saying, oh, shoot, where did this come from? How was it collected? Who collected it? What was the flow? To try to understand that. But data is generally just raw, unprocessed facts that are captured in some kind of way. And this is the challenge of data engineering, is to work with software engineers typically, capture that information, manipulate it, move it somewhere in an organized way, and make it available to access so then it can be used in some kind of way for business value. Hopefully, that's what we should be doing, unless we're just pretending to do data stuff. It should drive business value in some way.
Yeah, that makes a lot of sense. And I think that in business and even just in personal settings or in medical settings or in other industries, we usually encounter data in the form of a statistic of some kind. I'm just thinking of this little smartphone that I have that'll track things like usage time, or a lot of people have smartwatches that'll track like their heartbeat, their sleep patterns, their oxygen and respiration stuff, and it spits out numbers, I guess a reflection of some underlying reality. But I wonder if qualitative data just doesn't get enough love, like words and phrases, which we usually turn into frequencies so that we can count them. So I don't know if we're really nailing down this question or just talking around it. But what is data? I mean, it's stuff, but it's a lot of stuff that we usually encounter in the form of a number of some kind. And I think that leads to the next question that we've been thinking about. What is analytics? And I'm not sure that this is really my expertise. I'm more of an analysis guy. But what would you say is the difference between analysis and analytics? Another one of those hot buzzwords that we keep hearing about.
I think that in different circles, it means different things. In industry and within industries, it means different things. Often they're just used synonymously, which I'm totally fine with. I think that analytics and analysis can be used in the same way, but often analytics gives the connotation of some kind of computation behind it. So it's the process of analyzing data and information with some kind of computational component to it. And to your point about qualitative data is, up until recently, and has been extremely hard to find, to organize, to compute. Before, most databases were and data warehouses were predominantly in tables, which are rows and columns, so that they can stay organized. Where are you going to put an audio file? Where do you put a picture? Where do you put a video in there? But now with unstructured data lakes, we're able to at least retain and store that information. And now with new and updated machine learning, natural language processing models, computer vision, we're able to do a lot more analyzing than we were able to do before. So there's been a lot more technological advancement, which is helping us really access that qualitative data. I would guess that most data is qualitative in some way or unstructured in some way. And now these technological advancements, these new techniques are really helping us dive in there and get that information.
Yeah, so it sounds like you're saying that analytics, as you've practiced it, is always mediated by some sort of technology. So when I sit down with interview data and I go through it and start saying, okay, so what are the health beliefs? Like, what do people believe about this particular drug? What do they have concerns about? And I just start underlining stuff in the transcript. I don't know if that's necessarily data analytics, because that's just me building what we call in the social sciences a grounded theory. You have transcripts or some kind of output, and you just start putting different words and phrases into different boxes. And then you start theorizing what the different boxes mean and how they relate to each other so that you can better understand something under analysis. But it seems to me that that analytics always involve a computer at some point. And I wonder if it's related to older terms like cybernetics or something like that. That TICS in the word seems to be really descriptive, and I'm not sure I quite understand it. But I think analytics probably always has some sort of computational component, whether it's qualitative or quantitative data. And it's hard. I mean, is analytics hard? I mean, how specialized is this? Can anyone just pick up a computer and start doing this stuff? If you know a little bit of R, if you know a little bit of SQL, how sophisticated does it need to get?
Well, I think that you bring up a good point. I'm not sure analytics has to have a computer, but I know by some definitions it does. In my opinion, the process of collecting data, turning that data into information by providing context, by providing structure around that data, and then presenting it in such a way that the business can draw insights or actionable conclusions to drive business value. That whole process is data analytics. Whatever that process looks like in the moment, in that project, it's data analytics. So you could do it with a calculator. You could do it on pen and paper. To me, it's still data. You could do it on whiteboard, still data analytics. I think one of the biggest issues is that data analysts and technological folks in general start with the technology first. We start with the what's available, what's the end user tool, what's our visualization tool, what language are we going to use to extract and manipulate the data. We start with the technological side, which really should just be facilitating the end goal of business value. And so we sometimes get that backwards, where we really should start with what's the business need and what value are they trying to drive, and then work backwards from there and end at what data can we get to drive that value, versus starting with what data do we have, what can we do with it, and hopefully somebody in the business can find whatever we throw into production or throw into a dashboard valuable.
Yeah, and I think we should discuss the difference between data and information. But you've said a term a couple of times that I'm not sure I'm super familiar with as someone from the social sciences who doesn't have a super strong background in computer science. What's structured data and unstructured data? So I'm imagining that if you program a bot to go out and scrape all sorts of stuff from a website, you're going to get all kinds of output, probably in an Excel table or something. And maybe that's more unstructured, but maybe structured data already has like some sort of order imposed upon it. Am I barking up the right tree, or am I barking up the wrong tree there?
Yeah, that's 100% right. So structured data is standardized. It's clearly defined, it's searchable in some way. Often it's organized into tables and rows and columns. Unstructured data is stored in its native format. So, for instance, as an example, text is generally, if I put a comment on Twitter, LinkedIn, that's unstructured data. It's stored somewhere, but it's just in whatever sentence structure I had typed it in, versus like an Excel file in rows and columns. That would be structured, whereas the natural language processing or a video file or an audio file is just stored in its native format. It's just out there in a data lake or in an unstructured database waiting to be analyzed. But previously, I mean, tables are typically how, and data frames, which aren't 100% the same thing, but close enough. That's how we created relational databases, just tying one table to the other. Okay, this column in this table matches this column in this table, so we can line up these sets of data and information. But how do you align an audio file with a video or with a person? How do we say this person is attached to this audio file? So it's a new problem set. It's a more complicated one, but it's where the world's really going, and it's an excellent challenge for data engineers who are really building all these systems and structures, being able to tie all these pieces of information together.
Yeah, so in public health research, we often allude to the NHANES survey, which is a massive household survey that the US government does every few years. And it counts things like how many people are smoking, how many people are drinking alcohol, or recently they added marijuana or cannabis to the survey. And I imagine that would be an example of structured data. Like it's the same question that they ask year after year, and they tend to present it in relatively the same form, like because they want it to be comparable across different years. They want to see whether the number of cigarette smokers, for instance, has increased in 2024 compared to 2014. So would that be an example of structured data as well, like standardized, validated survey findings? But then unstructured could be something pretty wild, like video data, like 5,000 images from Google image search that are trying to figure out the influence of the Taylor Swift Time magazine photo of the year sort of thing, where she has her cat around her neck and people have spun off into lots of different variations. And I bring that up because my wife is a dedicated Swiftie, and so I've been hearing all about Benjamin Button, her cat, recently. But that might be something that some business somewhere might want to understand. What is the social trend, or what are the social forces driving that trend? So you can download all of these images, TikTok videos, YouTube shorts, and that's probably going to be pretty messy. It's probably going to be unstructured because there's not a consistent organization in it. Is that about right?
Yeah, typically structured data is quantitative and unstructured data is qualitative. And being able to use that that data is, if you can do that, then you're in such a good spot, right? We've got all this text, all this information, and maybe you're trying to run a predictive analysis and you don't know how to use the text. Well, maybe you can turn that text into a sentiment score, and now we've got something that we can plug into our analysis. So it's being able to move beyond the rows and columns and being able to integrate all this wide world of unstructured data, I believe is what's going to keep data analysts employable. I don't think they'll be able to be replaced by ChatGPT if they're able to think critically and be able to integrate all different kinds of data into their analysis.
And like you mentioned earlier, data is not just contemporaneous. You suggest it has a source, it has a history behind it. And I think it's hard for a lot of machine learning programs to really get that fuller context of what the data is or where the data came from, which can help determine how the data can be used, or to think of data ethics, how the data should be used. Just because a bunch of data is online doesn't necessarily mean that you should access it or that you should use it. You know, I could get a Tor browser and I could start browsing the dark web to see whose information is out there and do a data analysis of the types of people, to maybe develop personas of the types of people who are getting their credit cards stolen. But unless I have like specific research questions and probably some sort of ethical oversight committee, that could be some pretty hazardous work. Just because the data is out there doesn't mean that the data should be accessed or used. And maybe at some point we can talk about cleaning the data, because I think a lot of times when it comes to data security, we rely on a Where's Waldo approach. I'm sure my information is out there on the dark web somewhere, but so are millions of other people's data. And just by being a drop in this ocean, somehow I'll be safe. But maybe we can put a pin on that until another podcast. We've been dancing around this question of what's the difference between data and information. And I think maybe you've been using those two terms interchangeably, but how do you see those two terms as being different? Or how do you see them as being the same?
Both of them are the same in that they're facts, statistics, but information is typically data put into context. So in your example of machine learning, right, doesn't necessarily understand the context of the data. That's the challenge of the machine learning data scientist, data engineer, to put that into context, and two, to collaborate with business stakeholders, subject matter experts, to understand that context and be able to accurately move the data into a state that it still represents the truth. Too often, I think machine learning specialists, data scientists, data analysts are too removed from the business, that when they start manipulating the data, they start cleaning it, they start making trade-offs and determinations around, I've got all these null values. Do I replace them with 0 or the median or delete them? They're starting to make these decisions without fully understanding the context. One, they need to move fast, and I get that. But two, they need to collaborate with the business to make an informed decision. Because the best data teams, whether they're centralized, decentralized, or federated, view themselves as part of the business. They don't see themselves as separate from the business. They see their goals as part of driving business value. Like that's their whole being. If they're just building, pretend models, proof of concepts, talking about data, then that disconnect is what creates the bad reputation for data teams of, I don't even know what they do, because they're not driving business value. So it's turning raw data pieces, facts, statistics, add the context and clean it, manipulate it appropriately to put it into structure, information, and then presenting that to the business so that it meets their needs in some way that can drive actionable insights, some conclusion that the business can use to continue to drive that value.
Yeah. So could we say that information is tied to business goals somehow? So the goals of the organization are a key part of the context.
It could be. I don't think it has to be, though. I think information, as long as you're providing some kind of context, is still information. Because there can be useful information, there can be not useful information. It's still information. And that's where data analysts and data engineers get stuck in data modeling hell, is they're not looking at the business value, right? They're just creating tables, they're creating data flows and pipelines because that's their job, but it's not tied to the business value. And that's where we run into problems. That's where the data teams start being viewed as a liability rather than an asset. They're a cost center rather than a profit center.
So maybe that's another term we need to define: business value. Are you thinking specifically the value that the business brings to its clients, or are you thinking of the value that the analyst brings to the business, helping them deliver their products and services? Or is it both when we say business value?
It should be, it's really both. So the data teams aren't the end users. There's somebody on the end of that who needs to use the information in some way to get an insight to do their job better, whatever their job is. It might be to increase customer service strategy. It might be to sell better stuff. It might be to understand the customers better, whatever it is. So the business value is helping those end users do their job better, either saving them time, or enabling them in a way that they wouldn't have been able to do it before. So it's either doing the same thing but faster, or doing something new and better.
Okay, and you mentioned the word use in your last statement. And so it seems to me that data is like facts and statistics, but information is something is usable. And a lot of businesses, if not every business, needs to do something to convert data into information, because depending on their brand, their purposes, their strategies, not every bit of data that they collect or possess is necessarily useful. And you mentioned earlier sentiment scores. You can have a big pile of comments that you scraped off the web talking about your products and services, but it's really hard to take, I don't know, 5,000, 5 million comments and say, well, this is how it can inform our business strategy. Here's how it can inform what we do next. But through something like sentiment analysis, you can see, wow, people really hate us this week. What did we do? What did we say? What are some specific things about our product that they're not liking? And to me, that would be usable information. So the data points could be perhaps what the customers initially said as they were complaining about the product or service in a forum online. But the usable information in this case could be the sentiment score showing like negative impressions, negative feelings towards the product, and then maybe going even further to identify what specific patterns are we seeing in the data about that helps explain the sentiment score. What do people not like about the product or service, or what do people specifically like about the product or service?
And which should inform strategy. And then it's
Which
like,
should inform
what do they
strategy.
like? What do they not like? And based on that, what should we do, if anything? But
Yeah, so information is usable.
to your point
It
about
should be usable. As you
your
said, some information is not, but information should be usable.
to your point about collecting data, so many businesses bought into this. The data is the new oil, which is a bunch of BS. So then they collected and they stored as much as they could. But one, it's expensive. Now they're getting their cloud storage bills and they're like, oh shoot, it's very expensive to store all this information. And two, it's not in a state where they can use it or even should use it. So they've got all this useless data floating around somewhere. They're tracking key swipes, they're tracking everything. But now it's becoming a liability. One, it's expensive, but two, now states like California, Colorado's rolling this out. A lot of folks, unless the business has a carve out, have the right to delete their personal identifiable information, unless like a financial services firm or something has some kind of exception to that rule. Now you have to go and figure out where's all this information live for this person who has the right to delete it. Good luck. It's out there somewhere and you've collected it, and now it's a liability, because if you don't delete it, state regulators are going to come down on you like a hammer. GDPR in Europe, they have similar, not exactly the same, but they have similar rights. And so the more data you have, if it's not specifically being used, can be a liability to you. Similar with machine learning and building AI models. Now every board is asking every CTO, how are we using AI to augment our strategy? But California has the right to opt out of automated decision making. So how are you going to build a responsible AI model? How are you going to make sure that if somebody opts out of automated decision making, you can still function as a business? That everything that you have isn't revolved around that one feature of building AI into something. So it's a complex strategy, but more isn't always better. There's been new advancements in smaller databases and data structures, like DuckDB is betting on small, and they're doing very well. So it's not all up in the cloud, in the big giant databases. It's in a smaller structure, which is complementary and doing well. So I think businesses are starting to rethink their data strategies.
I kind of like the metaphor of data is the new oil. I mean, because I think that some of the critics of that metaphor think, oh yeah, well, like it's like a question of like value or like financial profitability. But like you suggested, data can be tricky to store. So can oil. When data spills, it gets really messy. So can oil. And I think that, we can't really have a modern society with a super high standard of living without oil. It's hard to have a really high powered business without data. And so a business is always going to need data. But maybe the trick is for some businesses, re-engineering themselves so that they can use their data more efficiently in a similar way that a lot of people are buying Teslas now because it's a more efficient vehicle. You're putting in a lot of the same gas as a lot of other vehicles. But I mean, I don't know. We are not sponsored by Elon Musk, so maybe I shouldn't use Tesla as an example. A hybrid car, like you can build a car to be more efficient with the gas that it has. The gas doesn't necessarily change, but you can re-engineer the vehicle to work better. And in a similar way, I think businesses can re-engineer themselves to use data more efficiently. And that's where data analytics can be really helpful. So you're not necessarily changing your fuel, but you can restructure your business so that your data flows are more efficient, so that you hire the right people, so you can change your data more effectively into information and this other word that we've been teasing, which is insights.
Yeah, insights is, on Amazon, they talk about the last mile before the drop off of the package. To me, that's analytics and insights, moving from information to insights. It's that last mile, right? We've got the material, we put it in a box. Now we need to get it delivered. And that's where analytics really can shine, is understanding their user base. They should be working very closely with the end user, understanding their jobs to be done, understanding the business impact so that they can prioritize all the different asks, and then be proactive with being able to say, oh, they should be the specialist with, here's what my business users need and here's what they're trying to accomplish. And I know all the data available to them and how I can manipulate and what kind of information I can provide them to drive insights. That stuff's often missed. It's usually, here's a pie chart. Hopefully this helps. Or it's reactive of, hey, show me last quarter's sales and who was the best and who was the worst. Okay, but why do you want to see it? What are we trying to drive? Like, it might seem obvious, but it may not be. What decision are you going to make based on this? What's the impact of that decision? Maybe that's not the best way to do it. Maybe you don't want to see a chart. Maybe you really just need raw data. Do you explore it? Do you not? Do you need it interactive? Do you not? Do you need it regularly? Do you not? Should I just tell you who the best and the worst person is? Why? Is it a training opportunity? Is it a compliance opportunity? What is it? And understanding all those answers and the needs of the end user can make a data analyst so much more effective, rather than just being a dashboard jockey and throwing together 1,000 workbooks on Tableau that never get used.
Yeah, so it seems to me that insights kind of implies that the analyst has generated information that is both valuable and perhaps new and surprising. And I think that's often the sign of a good data analytics project. You might be studying a topic that is very mundane, but if you can generate things that surprise you and that add real value to the business, then I think we're in the territory of insights. And that's how data analysts can really, I think, have good job security by generating not just data and not just information, but insights, things that are valuable and things that are potentially new and surprising for the business. And as you've alluded to several times, Andrew, a lot of this is not just a question of numbers or even a question of methods. It's a question of communication. And I tell my students all the time, you can have this beautiful pie chart, but it's not necessarily self-explanatory. I can, figure out what the colors mean. I can see the numbers, but maybe I was looking for a bar graph, or maybe that doesn't actually fit the data. Or even if I can see the whole pie, what's what's exciting? Is it all of the numbers? Is it just some of the numbers? How are things trending? And so a lot of data analytics, I think, comes down not just to the computational side of things, but to good communication, knowing who you're talking to, whether it be the end users, the executives, the other people on your team. And that's where I think a lot of really, really smart business people struggle, actually. There's a lot of people out there who are so good with statistics, are so good at compiling facts and making sense of them, but being nimble enough to communicate insights to different people throughout an organization, depending on the jobs they need to get done or want to get done, is really tricky. Maybe in a future podcast, we'll bring in some rhetoric and some theories from the ancients that can maybe help us sort out some of this data analytics stuff. Maybe all of our users will drop off if we try that, but that is part of the value proposition of Feels Like Technical Communication. Data is hard. Information is complex. Let's find ways to make it engaging and effective and persuasive for the people that it needs to be engaging and effective and persuasive for.
That's right. It's that story arc of, where are we? What's the conflict? What's the resolution? What's the takeaway? Being able to master that, but doing it in an honest and truthful way that gives accurate information and not just what you want people to hear. what the actual truth of the situation is can drive things forward, especially if things are bad. Identifying what's bad, why they're bad, and then moving to the strategic part. What can we do and why can we do it? And now let's make a decision of what are we going to do? Often business folks come to data folks in the middle of that. They're like, I think something's bad. Hey, give me some data on this. And the data analyst is like, oh, okay, let me go get it. And they send it back to them. And then they're like, oh, now give me some data on this. They're not getting the full story. They're not, let's use higher education where we both work as an example. Let's say they're worried about enrollment, and they have a hunch that enrollment's down. They say, hey, data analyst, give me some information on enrollment. You show them, they're like, oh, okay, enrollment's down. That doesn't give them any insights. Is it down everywhere? Is it down in one program? Where's the leak? Is it in between? Are applications down, or are we admitting people and then they're just not enrolling? If we admit people and they don't enroll, where do they go? Do they go to Stanford? Yeah, me too. I'd also go to Stanford. But where's this happening? Or are they joining and then they switch to a different program because you got professors who are mean and the program doesn't make any sense, or it's not competitive? Mm-hmm. Those are insights. Like, are they going to a more quote unquote prestigious university, or are they going somewhere where they got more financial aid? We don't know. But once we find out, then we can tailor our strategy. Oh, they're going places with more financial aid. We need to address that. Oh, they're going to a more quote unquote prestigious university with more awards. What can we do to improve the prestige of our whatever program? Those are the insights, and analysts often don't get involved there. They're just crossing their fingers and hoping that the end user can make those connections, where often they could use a lot of help in doing so.
Yeah, maybe a parallel example is something that I saw when I worked at a medical university, where the particular unit I was in had kind of an established message, a particular way of doing things, but sometimes they struggled to communicate their knowledge and expertise across the enterprise. And they ended up hiring someone with a background in brain science. And so people would go in and say, like, oh yeah, you need to do this because that's kind of what we've always done. And this is what we believe. Not really an insight, but when the neuroscientists could come in and say, okay, here's how your synapses work. Here's what the data actually says. Here's what the current research says. She was delivering, by and large, the exact same message as the old hands were doing. But because she had so much data and information behind what she was saying, she was able to deliver what I would consider to be insights. So potentially the same message as what everyone else was saying, but giving it so much more persuasive power because of the scientific weight behind what she was saying. And I think that's valuable for anyone in business. You can make a lot better business decisions potentially, or at least have a lot more surety about the direction you want to take if there is good data and good information behind what you're trying to do, as opposed to just doing business as usual or simply keeping the culture the way it's always been because that's the way it's always been. So I think data information can sometimes just reinforce the decisions you're already making, but that's valuable. But other times it requires you to really reconfigure your shop and do things in new and surprising and sometimes uncomfortable ways because you want to be aligned, ideally, with what your data is showing. And like you said, it's important to have the full story. I don't know if they're true, so maybe I shouldn't say it, but I will. But I've heard stories of people who have worked in consulting firms, and the consulting boss will say, like, oh yeah, that's a good number, but go back and give me a better number. Do a different statistical test. This is a client we want to please. Let's give them a better figure here. But that's potentially an ethical hazard. I think all statistical tests are subjective to a large extent, even in just the ones that you select. That's a subjective decision. And so being transparent, I think, about the bridges that the analyst is making between data and information, and then information to insights, is really, really critical. And if a business leader is working with a consultant that is not being transparent about the why behind each of their methods and how they're making the jump from data to information to insights, then maybe they should find another consultant.
100%. Yeah. Usually I've presented to boards at multiple Fortune 100 companies, and usually it's like a 1 to 3 page deck with just real broad, real specific insights, but it's just, here's the insight. And then it's like 80 pages of methodology and details in the appendix. And that's a good practice for all data analysts, is to understand the trade-offs. That's why I believe data analysts do need to know math. Sometimes, like, I don't think you need to know it to get a job, but in order to continue to move up and be more effective, you have to understand the trade-offs of everything you're doing. Like you noted, there's statistics is dealing with unknowns, and how do we quantify and handle those unknowns. There's trade-offs to all the different techniques, and there's different assumptions with all the different techniques. And when we manipulate data, we make trade-offs and decisions, and you just have to understand those and make them clear. When we run a machine learning model, maybe we run multiple of them and check their output and check their performance and see which one does better and why. But there's always trade-offs. Maybe it's, hey, we ran this logistic regression model and it's basic, but it performs pretty good, but it doesn't take a lot of compute and it's going to be cheap for us to run, versus, hey, we ran this deep learning neural network and it's more accurate, but it's going to take a lot of compute and be difficult to maintain. It's like, okay, well, the business may say, yeah, let's take the slightly less accurate one that's super cheap to run. Or, oh, no, I don't like that trade-off. I'm willing to pay more for the pain of being precise. So just understanding those trade-offs and making them clear is key to running an ethical and effective analytics or really any data profession.
Yeah, so I was thinking that the trade-off was in what the different statistical tests show, but you really expanded the purview and said, well, there's a trade-off with computing power. There's a trade-off in the comprehensibility of the data potentially. So the trade-offs are not just mathematical, they're also technological and they're social. And I think those are really key insights, really key considerations for both the analyst and for the business. Sometimes you just need to get a number fast and move on with the rest of the projects that you have on the docket. But other times you really do need to do a deep dive into the data, justify your moves at each point. But I would say, even if you're just doing like a shallow statistic, I guess, a quick statistic, it's still important to justify it and to acknowledge the limitations. What is the statistic showing? What is it not showing? And same thing with any sort of visualization. What is it showing? And also, what is it potentially not showing? And I think that acknowledging limitations not only builds the credibility of the analyst, but also potentially shows you what the next steps are. Like, this pie chart doesn't show me this whole other side of the business. Therefore, I know to go look at this whole other side of the business to get a fuller story. And as you mentioned, storytelling is such a big part of what we do. Not that we have to be novelists, not that we have to be poets, but that basic structure of problem, intervention, outcome is so key, especially for making findings accessible and understandable across business units.
And that's one thing that'll make you successful in any profession, but data especially, um, is being able to communicate clearly. And that's one reason I've found success is I connect really well and communicate with the business leaders because I was a business leader before I came into data. So I understand a little bit more about the strategic side and what their problems are and what their human resources and human capital problems are and managing a profit and loss, and a budget and building data programs that cater to their needs and understanding when is it time to be super precise and rigorous and when is it time to be directional and quick. Like, hey, we just need to know if we're moving in the right direction versus, hey, we need to know this precisely because we're going through an audit. So being able to make those trade-offs in your methodology, will be super helpful. Some analysts are incredibly rigorous and thoughtful, but they're too slow, and then they can't get stuff out the door because they're constantly trying to be perfect. And other analysts are never perfect, and they just move too fast, and then stuff breaks or it's not 100% right, and then you lose credibility in certain circumstances. So finding a balance between that is key in really any profession, but we do see it a lot in data.
Yeah, and a few times you've mentioned the importance of understanding what people do. And over here in UX and user experience, we sometimes use the term listening tour, which basically just means go out and meet the people in your company. Maybe they're going to be directly involved in your project, or maybe they're just a stakeholder, just a stakeholder. Maybe they're a stakeholder, someone who just needs to get permission for a project, but go out and learn what they actually do. And that helps you produce better results, whether they're directly on the project or not. But it also potentially can open the door to future projects. I mean, I've had a project shut down because apparently we didn't evangelize the results as well as we could have or should have at all levels of the organization. And someone walked through and said, "No, this project is donezo. I don't really understand the value of it. I don't really get what this is." And they had decision-making power to actually shut it down. And so there's that kind of self-preservation motive behind a listening tour as well. I mean, yes, you need to understand what people need so that you can serve them as an analyst, but you also need them to like you enough to, to give you permission and access and promote your success. Because depending on the project, you might need a lot of people involved to at least give you permission to do certain things, to give you access to certain things. But maybe to illustrate these differences between data and information insights, we could talk real quick about this little study we did for the AMWA journal, American Medical Writers Association journal, which was kind of a very short project, but it took us a while to find the right audience for it. Do you remember very much of those dark, dark years, those dark, dark months?
I do. Yes. Just as an overview, and you'd probably be better to explain the project better. Why don't you give an overview of what the project was looking for, and I can talk about my role in it.
Okay. So a few years ago, the Food and Drug Administration decided to hold a big meeting about cannabis, and they were specifically interested in collecting public opinion and scientific data about the cannabis plant. And this was not a policy meeting exactly, but it was a meeting that could inform policy down the road. Should cannabis be descheduled? Should it be decriminalized? How could it potentially be used safely? What does the data say that cannabis can actually address? What kinds of symptoms, for instance, and what is just hearsay? And as part of these public meetings, the FDA will typically open up a docket. And a docket is just an online folder of stuff. And any member of the public can submit comments or articles, data tables, really anything, and add it to the public record. And I thought that this was really interesting because I study cannabis from a user experience and a data analytics, I guess, sort of things. Not that I use cannabis myself, but I'm very interested in it from a public health perspective. And I just didn't see the FDA doing anything useful with all this stuff that they're collecting. I'm sure they do something behind the scenes, but I remember you mentioned at the time, Andrew, that a lot of data analytics programs are open source and public and potentially run afoul of the government's own security checks internally. So I hadn't seen anything published on this data. There were quite a few interesting comments, but I didn't have the ability to scrape the data myself, partly because regulations.gov can be sort of a spiny sort of website to work with. And so I turned to you and said, hey, there's lots of people uploading all kinds of comments about cannabis to this docket, to this digital folder. Can you potentially get it for me? And I think that's when you came on the scene.
Yeah, it was an interesting challenge because the FDA had just switched websites and it didn't move all the information over. It just started from ground zero. So everything on the old docket existed in one siloed area, and then everything after a certain date was in a different siloed area. So getting access to both of them was more difficult because the API only accessed the new information, which was the minority of the total data. So access was an issue, dealing with it, because as you noted, people put in attachments. It was a lot of free-form text. When people said, I'm from Georgia, they could have put a GA, GO. We saw like they could misspell Georgia. They could capitalize it, not capitalize it, as an example. People could submit multiple responses. So gathering that data, organizing it, and then making those decisions regarding trade-offs of how do we handle misspellings? How do we handle missing information? How do we handle attachments so that we can have a solid methodology that we can draw an actual insight from? So it was an interesting data challenge.
Yeah, and I think that we decided to take a shortcut and use a program called Lexamancer, which is basically a topic modeling program run by some company down in Australia, I believe. And if I remember right, I went through and corrected the misspellings. I felt like that was important for access and inclusion. I didn't want someone's voice to be left out of the data set just because they had a hard time spelling things like acetaminophen, or even the word opioid is kind of hard to spell on the keyboard. If you actually spell it out, you often step back and think, that's a really weird word. And I don't know, I do anyway. But that's one of the main arguments for potentially legalizing cannabis or pushing more cannabis-based medications that could potentially be a substitute for opioids. The data doesn't show that yet, but that's what people tend to believe. And as you mentioned, there were like a lot of gaps. The FDA site would prompt people to say where they were located, at least in which state where they were located. And we got just a messy data set where most people did not indicate where they were located. And we said, well, if they're not going to self-identify that information, then maybe in this case, it's not the best idea to go back and try to figure it out and impose a geolocation on them. So we developed that topic model just to find out what are people talking about with respect to cannabis. We ran, well, you ran, I'm not going to steal too much valor here. You ran some sentiment analysis and found it was a pretty neutral number, actually. It was kind of tricky to interpret. Then you did some Tableau maps to show the concentration of where the users or where the commenters were located, the top states. And in the report, I just said, hey, this is an incomplete data set, but this is what the data does show insofar as people self-identified their state. And that's how we handled like the slipperiness of the data, just being transparent about here's what it shows, here's what we don't know. Even though there's gaps in the data, we still think it's useful, but we're going to hedge any insights we draw. And so I would say that those raw FDA comments, all the stuff in the original docket, I would consider to be data. And then once we started to run tests, I would consider that information. But the insights came from trying to provide value to the readers of the American Medical Writers Association. And one of the interesting insights that maybe it didn't surprise you, but it surprised me, was that the commenters tended to use the words cannabis and marijuana differently. Cannabis tended to be used in very scientific contexts, and marijuana could be too, but it also tended to have a strong association in the data set with law enforcement. And so one of the insights that we came to was, well, in your public health messaging, perhaps you should prefer the term cannabis because it's potentially less stigmatizing. We don't know that for sure. It's just a possibility at this point that would require more validation. But to me, that was definitely an insight, something that was valuable to our readers and potentially new and surprising. And we also found, based on our topic model in particular, that people didn't seem to care very much about cannabis in general or marijuana in general, but they were very interested in specific cannabis products or specific cannabinoids such as CBD. They were very interested in treating specific symptoms such as pain and nausea or things like that. And so the insight that we distilled in the report was, well, rather than talking about cannabis or marijuana in general, try to target public health messaging down to a specific product such as CBD. I mean, CBD is a cannabinoid, but we treat it as if it's a product in a lot of popular contexts. Or talk about the connection between, say, cannabis products and nausea, or cannabis products and chronic pain, because that seems to be the needs and the interests and the values of the end users. And it's not a complete data set, of course, but I think that you could consider it a form of extreme sampling. And maybe that's another podcast topic, is how do you even sample your data? What are the advantages of different kinds of samples? And here we called it an extreme sample, where we had people who we figured, as a self-selecting population, they probably cared a lot about cannabis to begin with. And so they're probably going to be very pro-cannabis or very anti-cannabis, or maybe just very scientific about cannabis. But for those reasons, we felt that it was valuable, incomplete, but valuable. And in the research report, I tried to explain our reasoning at each step of the process and be pretty transparent about why we did certain things, what we captured, what we didn't capture, and phrase the insights in language that I thought was appropriately hedged. You don't want to be so doubtful about your own findings that the whole report is just garbage, but you do want to hedge them, I think, enough so that people can see, well, this is a possibility, this is a potential, as opposed to this is a hard and fast fact. And it's because, especially in the social sciences, users are always unpredictable. And I think just businesses tend to be pretty unpredictable themselves. And so hedging is an ethical way of showing the limitations of your data, but still holding up a lantern in the fog to try to light a way forward.
Excellent. Wonderful. Well, I think this was a great overview of data, information, and bridging the gap and removing the friction between information and insight through different techniques and a great use case. Michael, have a good weekend, and we will see you soon.
All right.